Namaste children, how are you all? I hope you are fine and welcome to today's math class. So we are discussing a new chapter. Till in the last class we were discussed about the boxes and sketches, chapter number 9, and today I am going to introduce a new chapter, that is 11, chapter number 11, area and its boundary. Area and its boundary. So in this lesson we are going to discuss about area and its boundary. That is, boundary is nothing but the perimeter. Perimeter and area is nothing but what it is, the space occupied by a closed figure. So both perimeter, that is boundary, and area, it is related to the closed figures. Closed figures like a circle or a rectangle or a square or a triangle or a rhombus or a parallelogram, any polygon. What is a polygon? Polygon is a closed figure made up of line segments. Made up of line segments. So now area is related to the space or the region occupied by a closed figure is called area. We have come across in class 4. So for example, if you place a book at one place, if you keep a book at one place, that book will occupy some space. That space occupied by the book is known as the area of the book. Similarly, if you place there one circular disc, it occupies some space on the floor. If you place it on the floor, then that space is known as area. Or if you want to construct a house, we will construct a house on the floor. So that floor will give you the area of the floor which is constructed. Similarly, like this, for the closed figures, we will find area. Then what is the units of area? The units of area are square units. Square units. If you measure them in centimeters, centimeter into centimeter, it is centimeter squared or square centimeter. Centimeter into centimeter is equals to centimeter square or square centimeter. Similarly, if you measure these in the units meters and meters, meter into meter is equals to meter square or square meter, etc. We have many units are there for area, like hectare. We will come across in the higher classes. And then, so what is area? Area is the space occupied by a closed figure. A closed figure is known as area, and its units are square units, that is centimeter square and meter square. Now, that is a perimeter. What is perimeter? For example, you started from point A, from this figure, and you are moving or you are walking along this line segments AB, BC, CD and AB. So you started from A and again you reached to A. That is, you are moving on this line segments, means you are covering one round along this figure, this closed figure. It may be a rectangle, or it may be a square, or it may be a circle. That is the total length of the boundary line of a closed figure. The total length of the boundary line of a closed figure is called perimeter. Or we call it as simply in our words, length of the boundary. Length of the boundary. And the units of perimeter are millimeters, centimeters, meters, etc. So what are the units of perimeter? Millimeter, centimeter, meter, etc. So perimeter is defined as, the definition of perimeter is the total length of a boundary line of a closed figure. Closed figure. See, this is a closed figure. Here it is a closed figure. Is this is a closed figure? No, it is not a closed figure. So we cannot find its area. We cannot find its area. So area is related to only the closed figures. So the space occupied by a closed figure is known as area. The total length of the boundary line of a closed figure is called its perimeter. In this class we are going to discuss about area and perimeter of some plane figures and their applications in the form of activities. Lot of activities were there. We will discuss those in detail. Now we have the meaning of perimeter and area of closed figures, their units. Is it clear, children? Now, here is a small activity. Whose slice is bigger? So, there are two friends, Perth and Guinea. They were discussing and they bought an arm papad. What is arm papad? Dried mango slice. Dried mango slice is known as arm papad. From a shop they brought two pieces. They brought piece A and piece B. Their pieces looked like this. So this is piece A and this is the piece of Perth, and we have the piece B is there, and this is the piece of the other friend Guinea. So you see the piece A, its length is 6 centimeters and width is 5 centimeters, whereas the length of piece B is 11 centimeters and width is 3 centimeters. So there is a conversation between them. Both could not make out whose pieces are bigger. So in these two pieces they could not identify whose piece is bigger. Whose piece is bigger in the sense which piece will occupy more area. Suggest some ways to find out whose piece is bigger and discuss. So whose piece is bigger in the sense what? We have to find the areas of both the pieces. So suggest a few ways to find their areas, and thereby we can say that piece A will have the bigger area or piece B will be the bigger or piece A will be the bigger, we can say easily. So there are many ways are there to find the what it is area of a closed figure. One among those, one of his friend, a friend of Perth and Guinea showed one way using small squares. So their friend has shown one way to find the area of this by dividing these pieces into small squares of 1 centimeter length. Small squares of 1 centimeter length. Now you see the length of piece A is 6 centimeters. The length of piece A is 6 centimeters. So 6 squares of side 1 centimeter can be arranged along its length. What is the length of this piece A? It is 6 centimeters. So we can place here what it is 6 squares, 1 and 2, 3, 4, 5, and it is 6. 6 pieces, 6 squares can be arranged along its length of side 1 centimeter. 1 centimeter. Now along its width, the width of the piece is 5 centimeters. So 5 squares can be arranged along its width. See here, this is 5 centimeters. So 1, 2, and this is 3, and it is 4. So this is 5. So it is not looks like a square, but I am drawing a rough diagram. So 5 centimeters are there. So we can arrange 5 small squares of side 1 centimeter along its width. Like this he arranged and he counted like this 1, 2, 3, 4. So now like this he arranged all these small squares and then he counted, that is converting them into small squares and counting all the squares. Now you see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 30 small squares of 1 centimeter are there. Therefore, the area of piece A is 30 centimeter square. 30 centimeter square. So similarly, we can find the area of piece B also. Thereby, we can conclude which piece is bigger. So here the length of this piece is 11 centimeters. So we can draw here 11 squares along its length and 3 squares along its width. As 3 centimeters is the width, so we can draw 3 squares along its width and 11 squares along its its length. 1, 2, 3 squares along its width, and along its length we can draw how many squares it is? 11 squares we can draw. Now it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and it is 11. So it is 11. So you take till here, this is 11. So 11 squares can be drawn along its length. So now along its length we have level there 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and along its width we have 3 centimeters are there. So 3 squares 1, 2, 3. Now you fill this with the squares. So what we get, how many squares we get? That will give you the area of the piece B. So how many squares we can arrange like this? In the piece B it is, see if you count all these squares, how many we will get it? See here, count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33 squares are there. Therefore, its area is 33 centimeter square. So, piece B area is 33 centimeter square. Piece A area is 30 centimeter square. Now, can you compare both 30 and 33? Which is greater? 33 is greater than 30. Therefore, proper that is piece B is bigger than the piece A. So one of his friend he suggested like this. So then another way, so one fellow he said that what it is, why is it necessary to count all these small squares? Instead of counting, I have a small tip is there. I have a small method, one more method is there. What is that? Count the number of squares along its length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 squares. And how many squares are there along its width? 1, 2, 3. Now multiply both. 11 into 3 it is 33. So it is 33 centimeter square. So instead of counting all the squares, identify the number of squares along its length. You see for this figure 1, 2, 3, 4, 5, 6. 6 into along its width how many squares are there? You count 1, 2, 3, 4 and 5. 6 into 5 multiply both will get 30 centimeter square is the area of piece A and piece B. So the first method it is draw all the squares of both the pieces 1 centimeter side and count all the squares. The other method it is along its length count how many pieces are there and along its width how many pieces are there you count, then you multiply, we will get the area of that piece. That is 11 into 3 33 centimeter square and 6 into 5 30 centimeter square. Now we can compare here the piece B is greater, therefore piece B is bigger. Piece B is bigger. Like this we can count. In the next class we will discuss by using the formulas we can find the areas of what type of figures they are. They are rectangles. Both are rectangles. We will study in the next class how to find area of a rectangle and square. Instead of counting the squares, we have the formulas are there. Using that formulas we will discuss. You see here, this is the textbook, and you see here in the orange shape we have this. This is this piece A and this is piece B. This will give you what it is 1 square centimeter. 1 square centimeter. See here, you can see this. Here, this I made this as what it is. This is for the first part. We will discuss. Now you see here, this is 11 centimeters long and 3 centimeters wide. 3 centimeters wide. So this is one rectangle, that is piece B. It is, and this is piece A, which is 6 centimeters long and 5 centimeters width. Sorry, 3 centimeters width. It is 5 centimeters. Originally it is 5 centimeters, and see, like this we have drawn, and we have to draw those squares, and we can identify which is bigger and which is smaller. Is it clear, children? Now we will discuss one more activity. Cover with stamps. So this stamp has an area. So this stamp has an area. See here, one stamp is there. It has an area of 4 square centimeters. Guess how many such stamps will cover this big rectangle, means how many stamps we can paste on this rectangle. Just guessing. So this is occupying this much space. Then like this, you see, this is 1, so 2, 3, 4, 5, 6, and it is 7. Like this, you can see here. This is 1, 2, 3, 4, 5, 6, 7. So approximately we are guessing it is 7 stamps we can place along its length, and along its width how many? This is 1 and 2, 3, 4. Approximately we can place 4 stamps along its width, and along its length we can place 7 stamps. So the area of each stamp is equals to, it is 4 square centimeters. It means that it is a square shaped, so its length will be how much it is? 2 centimeters, and this is also 2 centimeters. 2 into 2, it is 4 centimeter square, 4 square centimeter. That is the stamp. Now check your guess. Now we have guessed here along its length how many what it is stamps we can place. It is 7 stamps. Now length of each stamp, it is 2 centimeters. So 7 stamps means it is 7 into 2, 14 stamps. 7 into 2, it is 14 stamps along, 7 into 2, 14 centimeters is the length of this rectangle. So along its width, so this is 2 centimeters. If you place like this 4 stamps, one stamp is 2 centimeters. 4 stamps means 2 plus 2 plus 2, it is 8, or 2 into 4, 8. 8 centimeters will be the width, and 14 centimeters will be the what it is, the length. Now check your answer, check your guess. Measure the yellow rectangle. It is dash centimeters long. So now you see the textbook. So now this is your textbook. See here, measure this length by using a scale. So it looks, it is approximately, you see here, it is approximately 14 centimeters is the length, and measure its width also. So I hope it is visible to you. If not, you can do it on your own. It is along its width. The width of this, it is 8 centimeters is there. 8 centimeters is the width, and measure the yellow rectangle. It is dash centimeters long. 14 centimeters long. How many stamps can be arranged along its length? So for each 2 centimeters, 1 stamp. For 14 centimeters, how many we can arrange? 14 by 2, that is 2 sevens are 14. So 7 stamps can be arranged along its length. How wide is the rectangle? Wide means width. So how much we got when we measure this? It is 8 centimeters we got. And how many stamps can be placed along its width? For each 2 centimeters, 1 stamp. 8 centimeters means it is 4 stamps. 8 by 2. When we divide 8 with 2, we get 4. So how many stamps you can place along its width? It is 4. Now how many stamps are needed to cover this rectangle? How many stamps are needed? Just now I have explained. Along its length, it is 14 centimeters is the long. So along its length, we can place how many? 7. But it is 7 stamps. So 2, and this is 3, and it is 4, it is 5, and it is 6. This is 7. Roughly I have drawn. So 7 it is. So 7 stamps along its length, and along its width we have 4. So this is 3, and it is 4. So how many we can get? How many stamps we can get? The total in this rectangle: 1, 2, 3, 4, 5, 6, 7, and here 1, 2, 3, 4. So how many we can place? It is 7 into 4. That is 28 stamps we can place to cover that rectangle. How many? 28. Now what is the area of this rectangle? What is the area of this rectangle? So area of the rectangle is equals to, area of the rectangle is equals to the total area of the 28 stamps. One stamp area is 4 square centimeters. One stamp square area is 4 square centimeters. How many stamps are there here? We have 28 stamps are there. So 28 into 4. We will get what? 4 8s are 32. 4 2s are it is 8. 8 plus 3 it is 11. So 112 square centimeters will get area of this rectangle. Now what is the perimeter of the rectangle? Perimeter means sum of all the sides. So this is how much we got when we measured, it is 14 centimeters, and this is 14 centimeters. It is also 14 centimeters. So now this is, it is 8 centimeters. Width is 8 centimeters we got. So now add all. So how much will get all? That is 14 plus 14. How much will get? 4 plus 4, 8. 1 plus 1 is 2. 8 and 8 it is 16. So 28 plus 16, how much will get? 14. And 1 plus 1, 2. 2 plus 2 it is 4. 44 centimeters we will get. How much will get? 44 centimeters. Sum of the lengths of all the sides of the rectangle. 14 plus 8, 22. 22 plus 8, 30. 30 plus 14 it is 44 centimeters. So we have studied about this activity and we have guessed almost all. We reached to our guess. When we guess, we found that 7 stamps we can place along its length and 4 stamps can be placed along its width. Total it is 28 stamps we can place and its area will be 28 into 4. Why? Each stamp is having 4 square centimeters. So 28 into 4 it is 112 square centimeters is the area of that rectangle. So today we discussed finding the area of a rectangle, or that is plain figures, whatever it is a square, by dividing that into small squares and counting those small squares. Is it clear, children? We will discuss a few more diagrams. I will draw on the diagram and we will count these small squares and we will find the area of those figures. Now we will discuss a small activity. Find the areas of the following figures on small worksheet, like worksheet. So with knowledge what we have studied by counting the squares. See the first bit. This is along its length we have 1, 2, 3, 4 squares are there, and along its width we have 1, 2, 3, 3 squares are there. And if you count all the squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So what is its area? It is 12 centimeter square. That is how we got along its length 4 and along its width 3. 4 into 3 it is 12 centimeter square. Now you see the B bit we have along its length it is 1, 2, 3, 4, 5, and along its width if you consider this is 1, 2, 3, 4, 5, 6. So we know, we studied the length will be always longer than the width. So this will be the length 1, 2, 3, 4, 5, 6. 6 into along its width 1, 2, 3, 4, 5. So 6 into 5 it is 30 centimeter square. If you consider each small square is 1 centimeter square area. By counting also all this we get 30 centimeter square. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 30 square centimeters. What about bit C? Along its length 1, 2, 3, 4, 5, 6, 7, 8 and 9 into along its width 1, 2, 3. 3 squares are there. Therefore it is 9 into 3 it is 27 centimeter square. Even if we count all the small squares also, we will get 27 centimeter square as the area of figure C. So today what we discussed, it is by counting the small squares we can find the area of the figures by counting the small squares. In the next class we will discuss by using the formulas how to find area of a rectangle and a square and also perimeter. I hope today's concept you understood. Thank you very much and we will meet in the next class. Thank you once again.